right, and we're back to talking about reflecting with functions. This is our Unit 1, Lesson 9, and this begins on page 36 of your workbook. All right, and so we've already talked about translating functions in our prior lesson, and we're going to talk about reflecting functions. And you're going to see that there's going to be a lot in common what we did with our shapes and our segments when we did reflecting polygons a bit earlier in this unit. So what I would like you to do is go ahead and do the opener, pause the video, complete that problem, then turn it on, and let's see how you did. All right, so when you did this problem, we want to reflect KO over x equals -3. So I'm going to just go ahead and draw that vertical line in. So there's x equals -3 right here. All right, and hopefully you remembered that when we do a reflection, it's an isometry, so distance is preserved. So however far a point is from your line of reflection, it's going to be the same distance on the opposite side. So since O is 1, 2, 3, 4, 5, 6 to the right, O prime will end up on 6 to the left. So 1, 2, 3, 4, 5, 6. So we barely get O prime, all right, on our graph here. Now it looks like K prime is going to go off the graph because K prime is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then we go 10 to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. So K prime would end up over here somewhere, all right? And we really should end up with the same line, all right? It should be same size, same shape, everything, right? 'Cause everything is preserved since it's an isometry, all right? And when we look at standard 3.2 here, I can reflect a function in the coordinate plane. That same thing is going to happen, all right? So when we reflect a function, all right, so that distance is going to be preserved, all right? We should get the exact same graph, all right? It's just going to end up in a different position depending on how we reflect it. So now let's talk about, all right, let's look down here at the notes, okay? So when we reflect functions, just straighten this up here a little bit. All right, when we reflect functions, all right, there are two ways we can reflect a function. So the first way is just like what we did before, okay? So we can, all right, reflect over a given line. Just like what we've done before, right? So you say reflect over the x-axis, right? We can reflect over the y-axis, all right? Or we can reflect over any particular, all right, vertical line or horizontal line. So we can give you the line and we can ask you to reflect over that given line just like what we did before when we were reflecting our polygons, right, or our segments, those things like that. Now what's different is what we can also do with functions, all right, is we can take the opposite a value. All right, so by taking the opposite a value, that is going to create a reflection, all right, above or below your turning point if we're talking about a quadratic or an absolute value, which is the two things that, which are the two things that we're going to look at in this particular lesson. All right, so you can see here in our example we have 2 and we have -2 for our a values here, right? And so we know that our vertex is -1, -5, so we can see there, all right, and we can see that a +2 opens up, but then if I have the -2, it opens down, all right? So we're creating a reflection here, all right, and it's really about the horizontal line that goes through the vertex here, all right? So those are the two ways that we can reflect a function, all right? The first way is just like what we've been talking about. The second way is just to take the opposite a value. And notice if it had opened down to begin with, we could have made a positive and gone in the other direction, and that would have reflected it to open it up. All right, well, let's look at a couple of examples together. So let's flip the page and go to problem 37, and let's look at, all right, problem 1 here. All right, so we want to reflect y equals x squared over the x-axis, or excuse me, the y-axis. All right, and the y-axis, all right, is that vertical line right there. And I want you to notice something, all right? Notice that that vertical line goes through the vertex of our quadratic. That is also what we call the axis of symmetry. And so notice what this happens here. When we reflect over the y-axis, because it's symmetric to our line of reflection, we're going to really get the same shape. So the vertex is on the line of reflection, so it's not going to move left or right. But notice, this point is 1 to the right, so it would end up at 1 to the left. Well, this point is 1 to the left, so it ends up at 1 to the right. So we're just kind of reflecting over and onto each other. So when we reflect y equals x squared over the y-axis, all right, over the y-axis, we reflect it onto itself, so it actually looks just like it did before. All right, so now, all right, let's look at, all right, problem number 4. So we're going to skip here. I'm going to give you one of each type of reflection here. All right. Or actually, let's do problem 3 and 4 together here. Let's do 3 and 4. So let's go up to 3 here. All right. And we're going to reflect this over the x-axis. All right. So now, once again, here's our x-axis. So this becomes a lot like what we did in the opener. All right. So once again, those points are going to be the same distance, all right, away from that line of reflection. All right, so notice now if I look at my vertex is 4 above the x-axis here. So then that means it would end up with be 4 below, so down here. All right, and then the scale's not really great here. All right, and so then if I go up and look at for another point here, and maybe it looks like this point right here and this point. All right, looks like those are right on. All right, the corners of those boxes, so I can kind of count those off so that this is up, all right, 2, 4, 6, 8, 10, 12, all right, from our line of reflection. So that means that would be down 12 as well. So 2, 4, 6, 8, 10, 12. So that point would end up here. Same thing for this point. So I'd go down 12, and then I'd go down 12 again. And you can see that we get that same graph. All right, but now it's reflected over, all right, the x-axis, and it should look exactly the same. Same shape, same size, right? It's just now in a different position based on how we reflect it. All right, let's do one more together. And let's look at number 4, and let's just look at, like, adjusting, all right, that a value. So notice we are given the graph of y equals the absolute value of x plus 5 plus 6. We have a positive 1 for our a value. Our vertex is at negative 5, 6. And we want to draw the graph of negative x plus absolute value of x plus 5 plus 6. So it should look just like this graph, but instead of opening up, we now want that v to open down. All right, and so now, all right, and technically if you know how to graph an absolute value, you don't even have to know about reflections. You could just sketch the graph, but it's going to mirror. So the vertex is going to be in the same spot, right? And then I'm going to go down 1 over 1, down 1 over 1, right? And I'm just going to do that again and again, right, to create that same shape. And it really should look exactly the same width, right? And it's just going up, or it should be going down instead of up. All right, so those are the 2 types of reflections we can do with our functions. So now you finish this lesson. All right, check your answers on the answer key, and we will see you next time.